I am sharing my portions. Students, am I audible now? Tell me.
Yes, sir, you are audible.
Yes, sir.
My slides are visible. Are you seeing Boolean algebra?
Yes, sir.
Yes, sir.
Okay.
Yes, sir, visible.
So very simple thing. Try to understand. You will get everything from this PDF, that is copies, what you are seeing here. Okay. So I want to start the first module, Boolean algebra, that I have told you. So Boolean algebra means Boolean algebra. Have you studied at your 10+2 level?
Yes, sir.
Boolean algebra,
Yes,
logic
sir.
gate?
Yes, sir. Yes,
Yes, sir.
Okay, okay. So it will be easier for you to understand everything. Now, Boolean algebra is based on symbolic logic to express reasoning with the help of mathematical operations. Am I clear, students? Anytime, if you don't understand, you tell me, I shall repeat, no problem. So, do you agree this sentence?
Sir,
It
please
is based on symbolic logic to express reasoning with the help of mathematical operations. Huh? So many mathematical operations are there, and from this ultimately you will get different logic gates, universal logic gate, everything. Okay, so step by step I want to go ahead. Now, the operations in Boolean algebra are based on a set of postulates, you know. Yes, on a
Yes,
set
sir.
of postulates.
Yes, sir.
Using these postulates, some theorems are developed. These theorems are similar to the theorems in general algebra that you have studied from class 7. Okay. Now you see the 5 postulates are given below. These 5 postulates along with the sketches for the first 3 postulates. This is one, second, third. What is this? If I consider this is one switch, you see that dot means series combination. So 0 means this is open. Okay, open. This is open. So 0 dot. So if I give a signal here, what will be the signal here? You answer. If I give a signal here, simply, and what will be the output here? Tell me, anyone?
0.
These switches are
Zero.
not closed, open.
Yes, sir. Yes, sir.
So it will be 0, no signal. Yes or no?
Yes, sir.
So
Yes,
0
sir.
dot 0 is 0. The meaning have you got, students?
Yes,
Yes.
sir.
Okay.
Sir, sir,
Ah.
can you zoom it a bit, please?
Zoom. Okay, okay. If possible, I am seeing. Can you tell me where it has to be done?
Yes, sir. There
Sir,
is a plus sign on the upper
Plus,
side. Sir, on the
no.
left, there is a plus sign.
Sir, left.
Plus sign. Yes, yes, yes.
भाई एक
Okay.
बंदा बोल रहा
The plus minus sign for zoom in
Yes,
and
yes.
Yes, sir. It
yes,
is
sir.
okay
Yes,
now.
sir.
Now
okay
is it
now.
okay?
Yes,
sir.
sir.
Yes.
Fine,
Continue.
fine.
Ah. So 0 dot 0 is equal to 0. Have you got the meaning?
Yes, sir.
Okay.
Yes,
1
sir.
plus
Yes, sir.
1 will be equal to 1. Have you got the meaning here?
Yes, sir.
1. 1 means switch is closed. So it is conducting. So 1 plus 1. Okay. So you are giving here one signal. You will get here signal. Yes or no?
Yes, sir.
Yes, sir.
So 1 plus 1 is equal to 1. Next is 0 dot 1 is equal to 1 dot 0 is equal to 0. Why? 1 we are considering this is 1. So 0 dot 1 means if here is one signal, suppose, then 0 dot 1 means 0 dot 1 means this is 0 dot 1. This is 1 dot 0. So this will be 0, you know. Okay? Because if there is no input, what will be the output? 1 plus 0 is equal to 0 plus 1 is equal to 1. Are you getting, students, this meaning?
Yes, sir.
Yes, sir.
Yes,
One
sir.
thing,
Yes,
for simplicity, you forget this. Just go through this. Okay? So these are known to you from your 10+2 knowledge of gates or Boolean algebra. So 0 dot 0 just you consider that this is one simple mathematical algebra. So it will be 0. But 1 plus 1 in algebra it comes 2. But in Boolean algebra it is equal to 1. How? I have covered it already. So 0.1 is equal to 1.0 in your algebra. 1 plus 0 is equal to 0 plus 1 is equal to 1 is in your algebra. 1.1 is equal to 1. You agree with your mathematical algebra? 0 plus 0 is equal to 0. You also agree. 0 bar is equal to 1. 1 bar is equal to 0. So these operations or these 5 postulates, not only this, last is one, that is postulate 4. 0 bar is equal to 1. 1 bar is equal to 0. Postulate 5. X is equal to 1 if x is not equal to 0. X is equal to 0 if x is not equal to 1. Indicates that a circuit cannot assume both states simultaneously. Are you getting, students? Tell me.
Got it, sir.
Yes.
Huh?
Yes, sir.
Yes, sir.
Yes, sir.
I think all the things will come as a picture to you. And if you have any question, you just ask me after the end of the class, or if possible within the class also, no problem. But you see that within 6 lectures, I have to cover all these things, because within 18th, probably after that, your in-term exam will start. So, and or you will be in vacation for some days, I do not know exactly. So, the UG coordinator asked me to cover these 3 modules within 6 lectures. And as per demand of the student, I will cover this. At the same time, I shall give you review of the total subject. But if you give me some 1 or 2 extra classes, it will be more comfortable for me. So it's up to you to decide. Now, you see that theorem. This is very interesting, you see. The theorems of Boolean algebra are stated below. These theorems can be proved by using the postulates already stated. This can be proved by using the postulates. What are the postulates? These are the, okay? So this can be proved. You see that first is commutative law. Do you agree, students? You know? Anyone, you tell me. Yes or no? A dot B is equal to B dot A.
Yes, sir.
A plus B is equal to B plus A.
Yes,
Do you
sir.
agree?
Yes, sir.
Yes?
Yes, sir.
Okay.
Yes,
So,
sir.
question may be at your in-term examination that suppose the tick mark, that is MCQ, A dot B is equal to B dot A. Which one is correct? Suppose A dot B is not equal to B dot A. A dot B is equal to B dot A dot C. Like 4 options are there. So you have to give tick on this. A dot B is equal to B dot A. This will be the form of questions. Or suppose any question consisting of 3 or 4 marks. So then how many laws you know in Boolean algebra? You will answer commutative law, associative law, like this that I am telling you. So let me go ahead. Commutative law means A dot is B is equal to B dot A plus B is equal to B plus A. Now associative law, A dot B dot C is equal to A dot B dot C. A plus B plus C is equal to A, like your simple algebra. Up to this, have you any problem, students? Tell me.
No, sir.
No, sir.
Huh?
No, sir.
No,
No.
sir.
No,
Any
sir.
question
sir.
from your side
No, sir.
up to this?
No, sir.
No question? So are you getting everything?
Yes,
Okay.
sir.
Yes,
Yes,
sir.
sir.
You will
Yes,
see
sir.
that everything is very simple. After that, or seeing these PDF versions, I have, you see, the PDF versions are written in my own handwriting. Okay. So I have covered accordingly that if some portions of my lecture, suppose any student is missing, okay, so by going through this, he or she can easily understand that what I want to say. Okay, anyone, any layman also. Associative law. Next is you see distributive law. A dot V plus A dot C is equal to A dot V plus C. This also you agree. Yes, but in you see that in simple algebra you don't agree this. A plus B dot A plus C is equal to A plus BC. Do you agree in simple algebra?
No, sir.
This equation, students? Yes or
sir.
no?
No, sir.
No, sir.
No. But
No,
you see that up to this, all the equations you agree in comparison with your simple algebra. Yes or no? Up to this.
Yes, sir.
Yes.
Huh?
Yes, sir.
But
Yes,
this
sir.
you do not agree.
sir.
But you must not agree in connection with your algebra that A plus B in dot A plus C is coming is equal to A plus BC. But this is true distributive law in connection with Boolean algebra. I shall come to this point just after a few moments, if possible today or next day, that why it is coming. Okay. Now just wait. Identities law. A dot 1 is equal to A. A plus 0 is equal to A. So this is also coming from simple algebra, but these are called identities laws. Null elements. A dot 0 is equal to 0. A plus 1 is equal to 1. A plus 1 is equal to 1. Try to understand this. This is obeying your simple algebra, but this is not obeying. Okay, students? Huh? Huh?
Yes, sir.
Yes, sir.
What
Yes,
is
sir.
this? A plus 1 is
Yes.
equal to 1. In digital case, we have two systems, 0 and 1. 0 is considered as lower voltage or lower state. 1 is considered as higher voltage or higher state. So, there is no question of getting your next term above 1. That is why we are writing A plus 1 is equal to 1. Have you got the logic, students? Yes?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Now,
Yes,
complements.
sir.
Complements. Complements. A dot A bar is equal to 0. A plus A bar dot A bar is equal to 1. So this you have to keep in memory, because after this,
is only 0
whenever
and
I
1.
shall
Yes.
go for that is, so just let me see the syllabus in which portion this will be required. I am telling you, while I will go for your a simplification of Boolean expressions. This is included in your syllabus. You will see. So in that case, these theorems are very, very useful, because what is the heading? Simplification of Boolean expressions. Suppose one large expression is here. This will be simplified and will be represented by one logic gate. Try to understand what I am telling. You will get here with the help of number of expressions. Those expressions will be simplified using this, that is either commutative law, identities laws, whatever the case may be. With the help of this, those expressions will be simplified, and that equation, the final equation, will be converted to one law, that is circuit, that is logic circuit, with the help of logic gates that you have studied at your 10+2 level, and or not, NAND, like this. So very simple. Just let me go ahead. So A dot 0 will be, that is in case of simplification. If the term comes A dot 0, we will simply write 0. A plus 1 comes, we will write 1. Complements. A dot bar, we will write it is equal to 0. A plus A bar, we will write it is equal to 1. Idempotent property. A dot A is equal to A. It is not A square like your simple algebra. A plus A, it was 2A, or it is 2A, but here it is A, idempotent property. Absorption law, you see, what is this case? A plus AB is equal to A. A plus AB is equal to A. Why? Can you tell me? Why? How? With the help
Sir,
of
can-
earlier things. How
Yes,
I am
sir.
writing A plus
Common
AB
A,
is equal
then
to A?
sir,
If I
taking
take
A
common
common, 1
A
plus B is
for
1.
all
B
students, I
plus
am
1
1,
into
telling.
A
B
is
plus
A.
1 is 1, so it is A.
Okay, are you getting why it is equal to A?
Yes, sir.
Yes, sir.
Ah, for all
Sir,
students, I
please,
am
sir.
Yes, sir.
telling
One
A and
time.
B are different. If A is
that
0,
A is common. So 1 plus B. What is 1 plus B? It is equal
1.
to 1.
1.
One.
Because 1. So it is coming A. So this is a simple expression of simplifying Boolean expression also. But this is one absorption law. That is what I mean to say, that this is equal to A, or if I don't take it is equal to A, suppose I am simplifying this, A plus AB is equal to A, 1 plus B is 1 plus B is equal to 1, so it is equal to A. So in one sense, I can say this is nothing but simplification of Boolean expression. But it is not simplification. It is the one law which is coming also from simplification, but it is known as absorption law. Now, A dot A plus B is equal to A. A dot A plus B is equal to A. Involution A double bar is equal to A. Okay? Okay. A double bar is equal to A. Now,
Yes.
Yes, sir.
have you
Sir,
studied
A, B,
Demogram's theorem?
Yes,
Yes,
sir.
yes, sir.
Yes.
yes, sir.
Sir.
Yes, sir. Yes, sir.
Okay,
Computer.
okay, okay. So, but it is included
Yes,
in your
sir.
syllabus. Okay. Question may be on Demogram's theorem. Write Demogram's theorem. Just this. So, how much you will write, I am telling you, and what is the thing I am also expressing. You see, first case is Demogram's theorem. I think you know, students. A dot B dot C bar is equal to individual complement, that is this A plus A bar plus B bar plus C bar, and A plus B plus C bar is equal to A bar dot B bar dot C bar. But this is not De Morgan's theorem. This is the mathematical expressions of De Morgan's theorem. Now, can you tell me what will be the statement? This can be stated as, may I state? The complement. This is the complement. Okay? What is De Morgan's first theorem? The complement of the product of variables is equal to the sum of the complements of the individual variables. May I say like this, students?
Yes, sir, it is fine.
Huh?
yes, sir.
Yes, sir.
Yes,
Yes?
Yes.
Yes, sir.
No. Are you confused or the teaching is okay? You tell me.
It's
Huh?
great, sir.
Okay, sir.
Okay, sir.
Fine.
Okay, sir.
Okay.
It's fine, sir.
How we will rate? Good, excellent,
Hello,
very
hello.
good, bad. Huh?
Sir,
Students,
easiest topic.
is it okay?
Yes, sir.
Yes,
Very
sir.
good.
Yes, sir.
Okay.
Yes, sir.
Now,
Yes, sir.
okay.
Yes, sir.
Okay.
Very good.
Okay. So A dot B dot C is equal to A bar plus B bar plus C bar. No doubt about this. Yes?
No, sir.
Huh?
Yes,
So
sir.
this
No,
is
sir.
first theorem.
Not,
Second
sir.
theorem, A plus B plus C bar is equal to A bar dot B bar dot C bar. So what is De Morgan's second theorem? Can you tell me in what statement?
Sir, the complement of summation
Ah,
of the variables is
the
equal to
complement of, oh, you see,
summation of
that in
variables.
technical term, you have to say sum, okay, like this. So the complement of the sum of variables, okay? The complement, this is the complement of the sum of the variables is equal to the product of the individual complements of variables? Yes or no?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Yes.
So very simple. Yes. Now you see. And
Sir.
students,
Yeah, sir.
Demogram's theorem. It can be stated in words as follows. Listen to me one thing. After exam, you may say, sir, I have done all the things correct, but not good, got a EX. EX means highest grade, 90 to 99. Okay. So, suppose the question is, what is Demogram's theorem? So, one student is writing these two, okay? And the second student is writing in the form of this. It can be stated in words as follows. Who is correct? You say.
So the
Who
second
is
one.
correct? 100%?
Second one.
Second one. So, from my experience, I tell you that some students write only the first two. But he or she will get, if the marks is allotted is 4, he or she will get 1 or maximum 2. But
Sir,
this
both are
student
correct, sir.
who will write this, he or she will get, or to be more specific, you are writing these two sentences and then
Both,
you are
sir.
writing this. Number of first theorem you have told or written, then you are writing this. Second statement you are giving, then you are writing this. That means you are 100 out of 100. Are you getting my point, students?
Yes, sir.
Okay?
Yes, sir.
Yes.
Okay. So,
Yes,
in the class also,
Yes,
I
sir.
am telling you that if this is the question, how we will write also the answer. Okay. Now, it can be stated in words as follows that I have already stated. The complement of the product of variables. Yes. I should not repeat. And the second question, the complement of the sum of the variables is equal to the product of individual complements of variables. Okay. Now, where this Demogram's theorem, that is, this may be a question, where is it used? They are extensively used in the simplification of Boolean expressions and in the design of switching networks. Students, am I clear? So, from Demogram's theorem, what are the questions or possible questions? So, state Demogram's theorem. So you will write these two, and then if possible, with that is the mathematical expressions you are writing. Where is it used? Demogam's theorem. They are extensively used. All the things are in my PDF portions. Are extensively used in the simplification of Boolean expressions and in the design of switching networks. Students, am I clear to you?
Yes, sir.
Yes, sir.
Any
Yes,
problem?
Yes, sir.
Any problem?
No problem.
Okay. So now you see truth table. Have you any idea on truth table? I am coming to this portion.
Yes, sir.
Truth table
Yes,
for
Yes, sir.
verification of De Morgan's first theorem.
Yes, sir.
Do you know what is truth table?
Yes, sir. Yes, sir.
Will I state again or you know?
We know.
Truth table means suppose
Sir, state
input
again.
and output relation in the form of that is
Binary.
0 or 1. Okay, input will be given input or inputs will be given, that is in number of possible ways. Suppose I have two inputs A and B, capital A, capital B. You see, what are the possible ways? These two may be equal to 0. One may be 0, other may be 1. One may be 1, other than 0. One may be 1, other than 1. So, other than these four possible ways, is there any way? You tell me.
No,
Yes
sir.
or no?
No, sir.
No, sir.
No.
No,
So,
sir.
No,
No.
so
sir.
now you see truth table for verification of De Morgan's first theorem. Now, What was your first theorem? Oh, sorry. First theorem. What is this? A dot B dot C bar is equal to A bar plus B bar plus C bar. So this will have to prove, this will have to be proved using truth table. So how I shall, very simple, you see, truth table for verification of Demogam's first theorem. I have taken here two variables. Whenever I stated it, it had two variables, A and B, and C, three variables, A, B, and C. Now you see, I am taking truth table means A, B, take this table, A plus B bar, because I have to prove that A plus B, that is Demogam's theorem, A plus B bar should be equal to A bar dot B bar. Yes or no, students?
Yes, sir. Yes, sir.
Yes?
Yes,
Yes, sir.
Yes, sir.
So I have to write, that is take this table, A, B, I have to write four possible cases, 0, 0, 0, 1, 1, 0, 1, 1. Other than this, no possible way is there. Yes? Huh?
yes,
Had
sir.
it been three inputs, A, B, C, what are the possible cases? Can you
Eight,
tell
sir.
me?
Eight.
Eight.
Zero, one,
Eight cases.
0,
Eight
0,
cases, sir.
0. Suppose this is C. 0, 0, 0, 0, 0, 1, 0, 1, 1. Like this. I know that is
Yes,
this have
sir.
to be written. So here, to prove Demogam's first theorem, we have simplified from three variables to two variables. And our ultimate goal is to prove A plus B bar is equal to A bar dot B bar. Yes or no?
Yes, sir.
Okay?
Yes, sir.
Okay.
Yes, sir.
So you see, very simple. If I don't give you, you are so intelligent that you can do in any time. You see, A 0, 0 we have considered. What is A plus B? 0. Okay. What is A plus B bar? 1. Okay. So this you are getting today from my lecture also. But I think you know this before starting my lecture that A0, B0 means A plus B will be 0. And in that case, A plus B bar is equal to 1. Yes or no?
Yes, sir.
Yes.
yes, sir.
And also you have today also you have got this. Okay.
Yes, sir.
Now,
Yes, sir.
if A is 0, A bar is 1. If B is 0, B bar is 1. So what is A bar dot B bar? 1.
1.
So it is proved that A plus B bar is equal to A bar dot B bar. Students, simple. But
Yes, sir.
Yes, sir.
you see
Yes, sir.
that only thing that, suppose, try to understand what the students do. That suppose the question is, right, state Demogam's theorem. You will write these two statements with the help of expressions. You will write if possible. If it is not asked, you may write also. So that is the 100% case. Then the question may be, with the help of truth table, prove Demogam's first theorem or second theorem, anyone. So suppose do truth table for verification of Demogam's first theorem. Some students do accordingly. Only the first value he or she is giving, and then after he or she is writing. Hence, it is proved. Will he or she will get full marks, students? Because he or she has considered only one value. For four cases, you have to show. Because incidentally, this may be correct, that A plus B bar, here you have got 1, and here you have got 1. So it is not the sufficient of this proof. What are you getting? What I am telling you? That these four cases
sir.
you have to show here. Okay? So
Yes.
second case 0, 1,
Yes, sir. 4
1,
cases.
0. Will I go for clarification or go for the next slide? This
For next
will I
slide,
go
sir.
for all
Next,
these
next.
clarifications,
Next slide.
or you are getting
Yes, sir.
automatically?
We are getting, sir.
We are getting it.
So shall I proceed further?
Yes, sir.
Yes, sir.
Okay.
Yes,
Next,
sir. Yes, sir.
verification of Demogram second theorem. Same thing. A, B, you are considering. So 4 cases, 0, 0, 0, 1, 1, 0, 1, 1. And you are writing A dot B is equal to 0, 0, like this, you know. Okay. So A dot B bar is equal to this. So we are getting this, hence the proof. Yes or no? Yes?
Yes, sir.
Yes, sir. Yes, sir.
Yes, sir.
Now, up to this, from today, that is today, I have started from your, let me show. Boolean algebra. I have started from this. Then I have come to the theorems, number of theorems, distributive law, identities law, all these involution, then Demogram theorem I have stated, you have got with the help of expressions, then Demogram theorem statement, already it is written here, where it is used, you have got, and truth table for verification of Demogram's first theorem, truth table for Demogram's second theorem. Have you got, students, nicely all these?
Sir, I have a doubt.
Who
So
is doubt?
on the 35 page, point
Huh?
number 5.
Huh?
On the 35 page.
35 page.
Yes, sir.
My slide.
Yes, sir.
No. No case of 35. 103. I have started, you see, I am telling you that I
From
have
102.
started from slide number, let me show. Okay, this, okay. What is the slide number?
101.
101. You may ask
Yes,
me,
sir.
sir, why it is coming from 101? That is, I have the slide for the total subject, complete syllabus. Okay. If you ask me any question on this total syllabus, I am ready to give the answer. Okay, with the help of my system, means these PDF versions. That is why, but I have been allotted to take these 3 modules. That's why starting from 101. So no question of 35 now. You will get 35 whenever I will go for review.
Sir,
Okay?
can you please share the all
This
chapter
whole
slides
PDF.
also?
Huh? What
Sir,
is your
I
question?
think he.
Yes, sir, please.
Huh?
Sir, he
Tell
is
me.
Sir,
asking
can you
for
please share
102.
the
Sir,
all
share
chapter
the
slides
PDF
the
from
of
No,
all.
Sir, can you please share the full
if,
chapter?
listen to me.
Yes, sir.
If your requirement is same, any one only you tell, I am not getting your point. Anyone you tell.
Please
Sir.
upload the whole PDF of all the chapters.
I have to upload the that is PDF versions of the total syllabus.
Yes, sir.
Yes,
Please.
sir.
Yes,
Yes,
sir.
sir. In
Will it
MS
be
Teams.
convenient for you?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes,
Yes,
Okay,
sir.
okay,
Yes,
okay.
sir.
I shall give you.
It will be
Yes, sir.
great.
Very sir.
Yes, sir.
Upload
No
all
problem.
chapters. So it will be very helpful to us.
Okay, I shall give
Yes,
you.
sir,
No
because I'm
problem.
from the pro.
Thank
But
you, sir.
before that, let me complete my portion. Okay.
Okay, sir. Okay, sir.
Then
No problem.
I shall, you are getting the PDF versions of my portion automatically from the, that is recorded portion. Okay. You are getting, because this is one MS Team, you will get it automatically. Now, after that, I shall go through the review, and after that, that is last part, I shall give you the PDF versions of the total syllabus. No problem. And if you go through this, you will get automatically all the things. No problem. Okay. Now, you see. So, 35 number of lecture, that is 35, one student has asked me to show 35 number of slide. But there is, I have not today given you 35. 101.
Sir,
This is,
he's
Sir, I
asking.
think he is asking 102.
oh, 102. Okay.
102, sir.
Coming.
He's a 102.
Sir, in the upper left corner it is given na 35 or
Yes, sir.
59. He's asking that number.
Oh, okay, okay. Acha, the student who has asked me will ask me now, is it possible for you to ask me question over telephone?
Yes, sir. I want to ask the point number 5.
Huh?
So I want to ask the point number 5. I cannot understand here the a plus 1 is equal to 1 as
Okay. Which part? Which part? Tell me. Yeah.
sir, point number 5.
5. Okay.
Yes, sir.
Tell me. Which
Sir,
one?
sir,
This.
it must be 0.
Which one?
Sir, a plus 1 is equal to 1. So here a must be null element, that is 0.
Oh, no. Okay. I got your question. You will get automatically your answer. Just wait for one day. Okay. Okay. Your question is a plus 1 will be equal to 1 if and only if a is equal to 0. Yes or no?
Yes, sir.
Is it your statement?
Yes, sir.
Okay. So, immediately I am not telling you, yes, it is correct. But for simplification of Boolean expressions, there you will have A, B, C like this. So in that case, a plus 1 is equal to 1. Yes, have you got the answer? That is why you see that you have got here it is equal to a. Because a we are taking common, that I have clarified already. A you are taking common, so it is 1 plus b. 1 plus b is equal to 1. That's why it is equal to a. Now is it clear to you, students?
Yes, sir.
Yes?
Yes, sir.
Yes.
Yes, sir.
Okay. So now, okay, I have so many things to cover. Achha. So you have got verification of Demogram's first theorem, Demogram's second theorem. I repeat that you have to give your table accordingly. Yes? Don't forget for your semester exam. Now, this part, simplification of Boolean expressions. Simplification of Boolean expressions. Very simple case, but it is one intelligent thing also. Illustrations, that is some examples are given here. A dot A plus B. May I write here? A dot A plus A dot B. Yes, step by step you go. This is coming from the earlier properties. A dot A plus A dot B. What is A dot A? A. What is A dot B? AB.
AB.
I am taking common 1 plus B. What is 1 plus B? 1.
1.
Is equal to. Yes?
Yes, sir.
So that is the answer of that student's question, that whether it is 1, this B should be equal to 0. That was his question. So, okay, that is correct in one sense. But for simplifying, we have to write the general thing, 1 plus B is equal to 1. Have you got the answer, students? Huh?
Yes, sir.
Sir,
Yes.
while writing in the exam,
Achha.
we
So-
not need to mention
So I
that
want to tell you, listen to me very carefully. I want to tell you that this may be also a question in the semester exam, that simplify these Boolean expression. This is given here. And you have to write accordingly. You have to come to the end of the answer, that it is equal to A. That is, this total thing is simplified to A only. That is why it is called simplification of Boolean expressions. Yes? Huh? You are getting everything from my PDF portions that you see.
Yes,
If
sir.
you go through this, you will get like a book, no problem. Okay? Now, the next part, A dot A bar plus B. May I write this? A dot A bar plus AB. What is A dot A bar? 0 plus AB is equal to AB. Any doubt?
No doubt, sir.
So very simple, you see. Huh? Okay. Now
Yes,
the
sir.
third, x plus y, x plus z. May I write is equal to X, like your simple algebra, 4 components you will write x dot x plus x dot z plus y dot x plus y dot z. Yes. What is x dot x?
X.
X. What is x dot z? X dot z.
XZ.
X x y.
X dot Z will be X dot Z.
Okay. May I write this?
Yes, sir.
Yes,
Huh?
sir.
Yes.
And what is this? 1 plus z plus y means
1.
1.
so x plus y.
One, sir.
1.
That is, here I have given you some examples, but you go through this, no problem. Okay? Huh? Suppose
Yes, sir.
in the exam it is coming, simplify this Boolean expression, x plus y, x plus z. You will write it accordingly. Any doubt, students?
No doubt.
No, sir.
Okay.
No, sir.
Now, 4. A plus A bar dot B. May I write? A means A dot 1 plus A bar B. What is 1? May I write 1 plus B?
Yes, sir.
Yes, sir.
That is, what is the case actually? Instead of simplifying, I am making more complicated. By substituting 1 in place of 1, I am giving more complications, 1 plus B. But why? My ultimate target is to get simplification. Okay, simplified form. That's
Sir,
why in place of 1, I have written, not I have written, anyone will write in place of 1, 1 plus B. Yes, students?
Yes,
Okay.
sir.
Yes,
Now,
sir.
this is your
Yes, sir.
intelligence or aptitude, that in which place you will write which thing. That is like your 10 plus up to 10 mathematics or 10 plus 2 calculus, differential, integral, algebra. That suppose I am writing breaking 2 in the form 1 plus 1 to get some advantage. So that is the case also. This is one also one algebra. So in place of 1, I am writing 1 plus b. This is one common. So this is a plus ab plus a bar b is equal to a plus b, taking common, a plus a bar. So a plus b, what is this? It is equal to 1. May I write a plus b? Students?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
Okay. Okay. So today,
Sir, but one thing.
ah,
Sir, we can reduce the number of steps by first writing like distributive law over addition in the first
no.
statement only.
Whatever property you may take the help, no problem. If you get more simplified of this, okay, no problem. Okay. You can take the help of any property. Here, examples are given, and I have taken the help of one property. So you can take, suppose in place of 1, here I have written 1 plus b. You may write 1 plus a, no problem. Listen to me. I have written 1 plus b means you have to write 1 plus b. It is not, I am telling. In place of 1, you may write 1 plus a also. But you have to see that in place of 1, if I write 1 plus a, whether I am getting any simplification or not. If you get, okay, no problem. Have you got my answer, students?
Yes, sir.
Yes? Yes?
Yes, sir.
Okay. So today I have given you so many things, like starting from Boolean algebras, the properties, Demogram's theorem, simplification, proof of Demogram's theorem, everything I have given you. So that's all for today. Okay. So I hope because in the class also I have asked you questions, I have clarified each and every point at my best, and I hope the students from today's lecture have got everything nicely, isn't it? Have you got nicely? Students?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So today I am leaving. My next class will be, you tell me when I shall take my next class. Wednesday,
Sir,
10
on
10
Wednesday.
a.m.
Yes, sir. Sir, it's Wednesday schedule.
Yes,
Huh?
sir.
As per schedule,
Wednesday
is it on
schedule.
Wednesday?
Wednesday, 10 a.m.
10 a.m.
Okay,
Yes, sir.
so next class will be held on Wednesday at 10 a.m. Okay?
Okay, sir.
Okay.
Yes.
Okay,
Okay, sir. Thank you, sir.
students, for all students I am telling, you may take my contact number. You may write, I am telling 94. Are you writing?
Yes, sir.
Yes, sir.
Or
Yes, sir.
your section H friends have my contact number. You can collect from them 9434 788021. Okay. So any student, if any student has any question, you may ask me anytime. If I am busy there, this is my WhatsApp number also. You can write there, sir, I called you for this reason. Okay, I shall definitely call you back. Suppose I am
Sir,
busy in a
please tell
meeting
once more
or
the number.
okay,
Yes, sir.
or I
It is
am
a
seeing any missed call, and corresponding to missed call, I am getting one text message from that number writing that, sir, I was calling due to this reason. I shall definitely call you back. No problem.
Thank
Okay.
you, sir.
Sir, can you repeat your number?
Huh?
Sir,
Tell me.
please repeat your number.
Thank you, sir. Repeat the number, please.
Huh? Tell me.
Phone number repeat, sir.
Oh, repeat. 9434 788021. Okay.
Name, sir.
Huh?
अरे वो लिखा है.
See in the chat.
Okay, sir. Okay.
Yes, sir. Sir,
Yes, sir.
sir, can you give the slide today, please? Because if we read the slides before the class, it is very clear to us.
Okay, I shall give you. I shall give you. Okay. But for
Thank you,
that,
sir.
I require one that is common mail group.
Sir, you can
Mail
upload
group.
in MS.
Okay, okay,
Yes,
I
sir.
shall upload. No problem. No problem. Okay,
Sir,
okay,
please
okay.
all class. All
upload the
syllabus.
Sir, the full PDF.
Okay.
full PDF.
Okay, okay. Okay.
Yes, sir.
So today
Thank you very much,
I
sir.
am leaving. We are meeting on Wednesday at 10 a.m. Okay.
Okay, sir.
Yes, sir.
Okay, sir.
Yes,
Okay,
sir.
sir.
Thank you, sir. Thank you very much, sir.
Great
Thank you,
teacher.
sir.
Thank you very much, sir.
Okay, sir.
Okay.
Thank you, sir.
Thank you.
रिकॉर्डिंग ऑन है, रिकॉर्डिंग चलता ही रहेगा क्या?
सर को करना चाहिए था बंद.
স্যারটা কি ভালো রে সৌমিক।
সেই তো দেখছি ভাই, ইসিসি ডিপার্টমেন্টে স্যার গুলো খুব কুল টাইপের।
হ্যাঁ ভাই, বলছিলাম সবাই শোন, একটা কথা শোন। হ্যালো,
হ্যাঁ বল বল ভাই বল।
আমাদের এক্সট্রা ক্লাস দেবে, ঠিক আছে? তোর কি বলে না, আমার স্যারের মডিউল শেষ করার পরে এক্সট্রা ক্লাস নেবে, ঠিক আছে? ওখানে স্যার যে স্পেসিফাই করে কোশ্চেন গুলো বলবে, স্ট্রেস এই রেকর্ডিং চলছে নাকি? ভাই বেরো ওখান থেকে, বলবো না।
তুই বাঙালি গ্রুপটা বলে দে যা বলার।
আচ্ছা
ঠিক আছে, বলে দে।
কিন্তু স্যারটা খুব ভালো ছিল ভাই।
জানি,
বলা যেতেই পারে না যদি ইমপ্রেস হয়ে যায়।
এই এখানে কথা বলিস না, রেকর্ডিং
ইমপ্রেস হয়ে যদি পরীক্ষাটাই না নেয়, সবাইকে ফুল মার্কস।
ফারহান বেরো ভাই,
হ্যাঁ ঠিক আছে।
রেকর্ডিং চলছে।
ঠিক আছে, চল ভাই, টাটা।